The calculator portion of the test is so important, and you guys are going to use Desmos if you're stuck at home. If you're on campus, you'll use the TI Nspire, as you see a picture of right here. Really, the main things, if you're going to be given the graph, if you're given the graph of f, it's everything that they're asking you about it. Is it concave up? Basically, is it opening up? Is it increasing, decreasing? Just as the way it sounds and looks, you go with that. But what if they give you f prime? We're bringing back that same old thing. If f prime is positive, then f is increasing. I don't know how many times I have to write this year. And if f prime is negative, then f is decreasing. If f double prime is positive, then that tells you that f prime is increasing, which tells you that f is concave up. So if you're given the graph of f prime, if f prime is positive, then that tells you f is increasing. If f prime is increasing, then f is concave up. So realize the difference there between f prime being positive and f prime increasing. So if f prime is above the x-axis, f is increasing. If f prime is increasing, meaning it's going up, which you can see like this, look, down here it's below the x-axis, but it's increasing. So here, f would be concave up if this was f prime, right? If this is the graph of the derivative, f is concave up, but because it's negative, because it's below the x-axis, that means that f prime is negative, f is decreasing. So you probably want to watch that a couple times. So if f prime is negative below the x-axis, f is decreasing. But since the graph of f prime is going up, that means f prime is increasing, which tells us concavity. So please, please, please think about that. Distinguish that difference. It's really not that complicated once you let it click, and it's going to help you so much on that AP test. And then our first derivative test, we use that first derivative test that if we see at a certain spot, if it changes from positive to negative, then we can tell that it's increasing and then decreasing. That makes a maximum, and decreasing and then increasing makes it a minimum. So we can use that first derivative in looking at that graph. If it goes from above the x-axis to below the x-axis, that's a maximum. If it goes from below the x-axis to above the x-axis, then it's a minimum. That's f prime, right? Because if it's above, it's positive. If it's below, it's negative. If we're looking at f prime, that's what it tells us about f. Okay? So looking at this, on which interval is the graph of f decreasing? So just use Desmos. And we're going to look, this is the derivative they're giving us, so we're just going to graph it. If you're in the calculator portion of the test, you just graph it and determine when is it negative. And it's negative on this interval right here, 1.857 to 4.536. So since our derivative is negative there, then f is decreasing. So f prime's negative, meaning f is decreasing. Where do we have a relative minimum? So we're going to want to see the first derivative. We want to see it go from negative to positive, right? We want to see the first derivative do that. And we're given the first derivative. So let's graph it and see where does it go from negative to positive. It wants to know where. It just wants to know the x values. We can't tell the y values because we're not given f. We need f to plug it back into. Since we don't have f, we only have f prime. We can figure out where it occurs, but we can't actually calculate the actual value. But we can figure out what x value is, where it occurs, and start there. And so we're looking for when it goes from negative to positive, which happens right here. See, it's below the x-axis, then above. So our first derivative went from negative to positive there at 1. So x equals 1. Now what about concavity? Well, remember, for concavity, if f double prime is positive, we want it to be concave up. That tells us that f prime is increasing, which tells us that f is concave up. So if we have f prime, let's look to see where that is increasing, and that'll tell us where f is concave up. So here's our graph, and it's increasing to the left of -1. And so we'll put a union, that's the big U like that, and from 1 to infinity. There's different ways to state this. That's one way. And then last, how many points of inflection do we have? So this is f double prime. So pay attention to what they're giving you. You know, if we wanted points of inflection here, we'd figure out, okay, it would be there and there. Because notice f prime is increasing, then decreasing, then increasing. So those would be the two places where it changes. But they're actually giving us f double prime here. So we want to see, where does it change? We want to see changes there, right? If it goes from negative positive to negative, those would be points of inflection if it's a second derivative changing. So when is it above and below? When is it changing from above and below the axis? And notice they're restricting our interval. Pay attention to that, from 1 to 4, because I'm looking at this trig and I'm like, man, this could be doing this forever and ever and ever. So let me go ahead and put sine of x squared plus cosine of 2x. This is brutal. Minus 1/2. So it's changing all the time, right? So let me just restrict our window. And if you guys have the calculators, I'll have to teach you how to do that. If you're using Desmos, you did the Desmos project before, so you know what this is. You know how to do this. So there we go. Restricted our window from 1 to 4. Changes there, 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 and there. So it has 4 points of inflection on that interval.